Hi, I'm Kat and this is my physical final project. Thank you Mr. Tim for making this a project instead of a test. I really appreciate having time to sleep. So, let's get started with the first unit. Matter and energy. Our first topic will be atoms and molecules. This is a neutron. This is a proton. This is an electron. And this is how an atom works. Protons and neutrons are stuck together in a clump while electrons orbit around them. So what are atoms? Atoms are everything. What are simple molecules? They're basically, in simple terms, atoms combined together. An example of a simple molecule is water. Water is H2O, whereas there are two hydrogen atoms attached to one oxygen atom. Now let's draw an extended structure of a substance in vinegar. Let's move on to our next topic in this unit, states of matter. Our three states of matter are solid, liquid, and gas. So how do atoms move in them? For solid, they vibrate in place. For liquid, they slide past each other. For gas, they move freely. In order to demonstrate how matter changes, let's draw a phase chart. This indicates that as temperature rises, solid turns into liquid, then gas, and its heat energy rises too. Let's take our friend Heart as an example. He is currently a solid. As thermal energy rises, he is starting to melt. He is now a liquid. Now he is starting to evaporate. He now turns into water vapor, which is a gas. And that's the life cycle of our friend Heart. Let's move on to our next unit, chemical interactions. We now analyze whether a chemical reaction occurred or not. So, what is a chemical reaction? In a chemical reaction, atoms are rearranged to create something new. Since not all chemical reactions are apparent, these are the signs that a chemical reaction occurred. A color change, a formation of precipitate, a formation of a gas, and temperature change. Let's make a sunny side up as an example. This is how the egg started. As the egg is dropped into the pan, the temperature rises, there are formation of gas, the bubbles, and the egg white turns from clear to white. This means that a chemical reaction has occurred. Let's move on to the next topic in this unit, mass is conserved. The law of conservation of mass states that in a chemical reaction, atoms are neither created nor destroyed. This means that no atoms is disappearing out of thin air or created out of nothing. So let's light up a candle as an example. In here, the atoms from the chemical reactions is changed into heat energy, so that's why it's still conserved. Now let's go on to our next topic, exo/endothermic reaction. An exothermic reaction is when a reaction in which energy is released, while an endo is when a reaction in which energy is absorbed. Let's turn on a stove as an example. This is an exothermic reaction because the chemical reaction from gas is turned into heat energy. Let's go on to our next unit. Our third unit is motion and forces. Our first topic will be Newton's third law. What is Newton's third law? Newton's third law states that for every action, there's an equal and opposite reaction. Let's take two batteries colliding as an example. Because the batteries went in with the same force, after they collided, they went out with the same force. Okay, let's move on to our second topic in motion forces, change in motion. The change in an object's motion depends on the sum of the forces exerted on the object and the mass of the object. Also, the more mass an object has, the more friction will act upon it. Let's weigh this eraser's weight. 9.8 grams. I can push this eraser easily because it is light, therefore there is less friction going against me. Let's try pushing this heavy looking bag. I can't push this bag easily because it is heavy, therefore there is more friction going against me. Our fourth unit will be light and sound, and our first topic is amplitude of wave. This is the amplitude of a wave and measures loudness. The following will demonstrate the amplitude of a wave. Our second topic for this unit will be traveling of waves. Waves can be absorbed, reflected, or transmitted. This is a wave that's being reflected. The law of reflection states that the angle of the wave that goes in equals the angle of the wave that goes out. This is a wave that's being absorbed. The material that it goes through will probably be a wall. This is a wave that's being transmitted through a material. This material will probably be a window. This is a mirror. The light waves are reflected to show us what's on the opposite side. This is a window. The light waves are transmitted through it in order for us to see what's on the outside. Sunglasses are used to protect our eyes from UV light, so that's why it's absorbing UV light. Our last unit will be electricity and magnetism. The first topic for this unit will be the factors that affect the strength of electric and magnetic forces. Let's start with the factors that affect electric force. There are three reasons why electric force is affected. The first reason is imbalance of charge. The more the two charges differ, the greater the electricity. Let's take lightning as an example. First, the particles inside the storm cloud will separate into negative and positive charges through collision. Negative charges goes to the bottom. The negative charges from the cloud turns the ground into positive charge through contact. After that, static electricity is discharged. The charge from the air jumps to the ground. This causes thunder and lightning. The second reason is the voltage of the power source. The more volts a power source has, the more electricity it will create. Take a 6 volts battery and a 110 volts plug for example. The 110 volts plug will create more electricity because it has more volts. The third reason is the quality of conductors. The conductors are usually the connectors in a circuit. Take this map circuit for example. The lines are the conductors. Good conductors contain iron, steel, and metal, and bad ones are plastic, rubber, and yarn. The wires inside the charger is a good conductor, that's why it can send electricity to charge the phone. Plastic, however, is a bad conductor, that's why it's the wrapper around, so you won't get electric shock from holding it. Let's move on to the factors that affect magnetic force. The first reason is the distance between magnets. If they're too far away, they won't attract, even though the poles are supposed to. If they inch closer and point at the right poles, they will attract. The second reason revolves around magnetic domains. Magnetic domain is a group of atoms whose magnetic field are aligned. This is how a non-magnetic material would look like. Examples of these are pens, plastic, and gum. This is how a magnetic material looks like. Examples of these are nails and iron. This is how a magnet looks like. Examples of magnets are just magnets. The last reason is where the pole is strongest. The pole is strongest usually is at the magnetic poles. When the magnets are aligned vertically like that, they won't get as strong as a pole as the second diagram because they're not pointing each other at the poles. The last topic in the last unit will be on circuits. What is a circuit? A circuit is a closed path through which a continuous charge can flow. To build a circuit, you need a voltage source, a switch, conductors, and a resistor. Now that we have our stuff gathered, let's build it. We've made a working light bulb. This is important in everyday life because we use electricity and light bulbs play a big role in that. And that marks the end of Kat's physical science project.